Welcome, my dear students. In today's video, we are going to see about circular motion. Okay, we are going to see the concepts and then we'll solve two JEE advanced questions. Okay, so first we need to know what is the most important concepts. First, let us assume that a particle travels in a. Wait, my God. Let's assume that the particle is going to travel in a circular motion. I am very bad at drawing, so let me draw a smaller circle. Okay. I think there is no need to draw such a big circle. So let's draw a smaller circle. So this is the radius r, and suppose the point, this is point A and the particle travels up to point B. So there is some kind of angular displacement which we can call it as theta. And this is the path length. Maybe this path length, let me denote as L. So we can write the relation that is L is equal to r into theta. The relation number 1. Secondly, at each and every point of the motion, we can have one linear velocity which is tangential to the direction of the particle in which it is traveling. So this is going to make 90 degree with the radius, from the with the point of center of circle at any instant. Okay, the velocity x linear velocity always acts perpendicular. Okay, this is one point, and then we need to know that there is some kind of angular velocity in the particle which can be denoted by v by r. This is relation number 2. And obviously, if there is a velocity is constant, then no problem. If constant velocity is going to change with time, then obviously some kind of angular acceleration is going to be there. That angular acceleration can be written as alpha, which is equal to change in omega by time. Okay, these quantities, no, sorry, these three formulas you need to know. Okay, now we will study some kinematics about circular motion. So while coming to the part of kinematics, we can tell that you have studied S is equal to ut plus half a t square. Similarly, you can write theta is equal to ut. U is omega initial t plus half angular acceleration alpha t square. So this is one equation that you already know. This is in different words, but the equation is same. Now another v square is equal to u square plus 2s. So we can take as omega final square equal to omega initial square plus 2 alpha into theta. Sorry, not s. Not s, not s. 2 alpha into theta. Okay, this is one relation that you need to know. And thirdly, v is equal to u plus at, omega final equal to omega initial plus alpha into t. This is also one relation that you need to know. Is there anything else I have left? The three equations, no? Or four is there? This is equal to ut, v square minus u square equal to 2s, v is equal to u plus at. I think that's all. Yeah, that's all. Okay, these things you need to know. Secondly, what else I need to teach? First you copy this. Okay, pause and copy. Let me erase now. Just check once the video is clear or not. Clear. So now let me assume. See now perfect circle is coming, but initially when I'm trying, at that time perfect circle won't come. Let's say the particle is here, and the particle is not moving with uniform velocity. Then some kind of acceleration is going to happen. That is for sure. What kind of acceleration? Tangential acceleration is going to happen. At the same time, some kind of acceleration is going to act inverse also. Okay, that because of this acceleration only the particle is changing its direction, or else it will go like this. The reason why it is changing the direction and moving in a circular motion is due to this component of acceleration. Now, can you tell that what is the resultant of this acceleration and this acceleration? It's going to point somewhere like somewhat like this. This is going to be the net acceleration. Okay, now we can represent this as A is equal to A square equal to AC square plus AT square. Okay, this is the relation between net. Okay, let me write n here so that it is net acceleration. Okay, sometimes normal acceleration. What is normal acceleration? Normal acceleration is also called as tangential acceleration. It is right. Yeah, tangential acceleration. Hmm. Okay. Next, but here it is net acceleration, not normal acceleration. Okay, and you need to get not get confused. So let me write full net even. So A net square is equal to A centripetal. What is this AC now? AC is centripetal acceleration. AC is nothing but centripetal acceleration. What is AT? Tangential acceleration. Okay, this centripetal is tangential. And the relation between the centripetal and tangential, no. The relation between the net acceleration and the centripetal and the tangential we have written over here. Now the next thing that you need to know is that what are the magnitude of these accelerations? The centripetal acceleration can be denoted as v square, linear velocity square divided by its radius, or we can write it as omega square r. Omega, you know, it is angular velocity. Okay, what is tangential acceleration? Tangential acceleration can be written as r into alpha. Okay, this is one case. So these three things now you need to know. If they are asking centripetal force, no, then you need to write it as m omega square. Just add one m, that's all. M omega square or mv square by r or mv square divided by r. Okay. Or if they are asking tangential force, simple mr alpha. Okay. So it's the force acting on the particles. See, centrifugal force is there one, which is trying to pull the block away from the circular motion. Okay, that we'll discuss. Centrifugal force. But magnitude wise, centripetal force and centrifugal force have same formula. So that only direction is going to change. The centripetal, this one, this is centrifugal. This is centripetal only what I have written. But for centrifugal also, same formulas. Okay. Just the direction of the force will change. So I think there is no need to discuss centrifugal also again. If centripetal force is acting towards the center of the circle, this is going to act in the opposite direction. That is making an 180-degree angle with the centripetal. Okay, hope you are clear. We'll just erase this. Now let's say there is one situation. Alright, up to now what you have seen is CBSE. Now let's get into the GE part. Okay, now let's get into the GE part. See, this is very important. Up to this, what you have studied, that don't tell that is difficult at all because that is very easy concepts. Everyone will know. Hey, everyone will start solving. So now we are going to assume that tangential acceleration is equal to the centripetal acceleration. Okay, this is the case we are going to assume. Tangential acceleration is equal to centripetal acceleration. Then what will happen? We can. How can we write tangential acceleration? What is tangential acceleration first? Rate of change of velocity, can I write it as tangential acceleration? Yes, I can write it, no? Rate of change of velocity, because velocity is going to change. Am I right? Am I making any mistake? See, here. You need to know one thing. What did I say? Rate of change of velocity. But do you think rate of change of velocity is going to be tangential acceleration? Do you think velocity and speed both is same? But okay. Wait. I have to stay here, or else the screen is getting blurred. No. Okay. So, do you think that the tangential acceleration, sorry, velocity and speed is same? Velocity is also showing direction, and speed is just showing its magnitude. So speed can be constant, but the velocity can't be constant. Okay. So basically, what we can write here is you can't write rate of change of velocity. What I told was wrong. Okay. That part you need to be clear. It is not rate of change of velocity. It is rate of change of speed. In this case, why? Because each and every point on the circular motion. Leave this. Leave this. Okay. Each and every point, the direction of the velocity is going to be changed. The direction is changing. How can you tell that the velocity is a constant? So it's not possible, no? So that is why we are calling it as rate of change of speed. That can be written as dv by dt equal to what is centripetal force you can write. Can we write mv square? Sorry, v square by r. Yeah, we can write v square by r. Is there any mistake? No, no. dv by dt I have written as v square by r. It is correct because the assumed situation is like that. Now I am going to transpose this v square that side. So dv by v square equal to dt by r. Is that clear? Now let's get into the J part. Okay, we are going to apply integral. We are going to apply integral when zero time is equal to zero. Velocity is okay. Let's call it as u velocity. Okay, u not, and at time is equal to t. It's going to attain a velocity v. Because if it is zero, na the calculation is so simple. But we don't like simple things in our life, so that let's make it complicated. What is 1 by v square Farnada integral? V per minus 2. Minus 2 now, minus 2 plus 1 by minus 2 plus 1. Minus 1 by v. Minus 1 by v. What is the limit? U naught to v. So here we can call it as t by r. From 0 to t only, so no problem. Directly you can write. Now while expanding this, you can get 1 by u naught minus 1 by v equal to t by r. From this, if you take 1 by v now, you will get 1 by u naught minus t by r. If you simplify this now, you will get velocity. Okay, wait. Let's simplify here. Let's not do it there. Let's do it here. If you simplify that velocity, you will get u naught r divided by r minus u naught into t. I am not wrong. Okay. Now, how can I write velocity? Change in distance by change in time, which is going to be u naught by r minus u naught t. Now I'm going to transfer this dt here, so you can write it as dx is equal to u naught r into. I'm telling why I'm writing separately this one. R minus u naught into t dt. Now that I'm going to apply integral again, this is going to be constant. That's why I'm written separately. Okay, now I hope you can understand. From x is equal to 0 to how much times we are going to do now? We are going to calculate up to one revolution. Okay, up to one revolution we are going to calculate how much time it is going to take. How much time the particle is going to take to complete one revolution. If what tangential acceleration and centripetal acceleration is same. Okay, so let's say this is 2 pi then in that case. 2 pi r no. See, here we are differentiating times 0 to t. So what you will get 2 pi r minus 0. So let me write directly 2 pi r equal to u naught r. What is integral of 1 by r minus u naught t? This is going to be ln base e. Okay, for your avoiding confusion, let's write log base e r minus u naught t divided by what is the coefficient of this t? Minus u naught divided This minus u naught cancel. So this minus will go there to become minus 2 pi r. Fine. And this r also cancel. R cancel. Now can I write that here limit is there, huh? Limit is there. T to 0. Now apply the limit minus 2 pi r. Say minus 2 pi equal to, can I write it as log base e r minus u naught t by minus r minus u naught t minus log base e r. Can I write, or to write two times? I'll write two times better for your clarity. R minus u naught t minus log e times r. Hope you can understand now. Now you can tell that log a minus log b formula. Minus 2 pi equal to log of base e r minus u naught t by r. This we can write it as e power, I am transposing this e here, so it will become e power minus 2 pi equal to, this r will get cancelled with this 1 minus u naught t by r. If I transpose this part, negative part, that means I get u naught t by r equal to 1 minus e power minus 2 pi. Okay, if I am wanting this t, then I can write it as t is equal to r by u naught into 1 minus 1 minus e power minus 2 pi. So this is going to be your time taken to complete one revolution. So this is only JEE students, JEE part. Okay. So these kind of questions now you can expect in JEE means standard formulas. This is, you can memorize. You can memorize this result better. This result now you can memorize if you don't want these derivations. And some students, you should not come and tell me in the comment box that, sir, I don't know integration, sir. Don't tell me like that, right? That will be taught every coaching center, wherever you are. Every coaching center they will teach that. Okay, without knowing that you can't do any physics. So don't tell that it's not taught. I hope you know the concept of friction. You just pause and read, or else if you didn't pause now, I'll give time 2 seconds faster. I hope you have passed 2 seconds over. Why I am teaching in YouTube now? If I teach in Zoom means, if you don't understand, again you need someone to teach again. But in YouTube you can rewind and check. It's the beauty of teaching in YouTube. Okay, and there is no need for that inferiority complex that some people is having. No, they won't be asking the doubts. A doubt now, if it is one time class means you will get doubt. If you are able to rewind and watch, then what is going to be the doubt here? The only doubt is how you integrated. That integration you must know. If you don't know, then that is a problem. That I can't help. Okay. Means that you didn't properly focus in your coaching classes. That is not our fault. That is your fault. Okay, now let's see one last concept and we'll just do the two J advanced questions and then we'll see the remaining part of the circular motion in another class. Okay, how much time it has taken? 19 minutes. I don't know. Okay, so 19 minutes class means somewhat 30 minutes only maximum we can take one class. Okay, now let's say that this is a block of mass m and I am applying some force F and this is not moving. This mass is not moving even after I am applying a force F now. That means that some kind of friction is acting in the opposite direction, which is preventing the block from motion. So this is getting equalized with this. Okay, this is cancelling out each other. But this will happen only up to a certain limit. If you apply more force, now at some point of time the body of mass m will start moving. So at the instant up to which the block will stay at rest, this we call as F max, and this will called as FL, limiting friction. So what is the limiting friction now? FL, which is also called as maximum static friction. Static na rest, which will be equal to mu s mg, or else you keep it as mu s m, or else later no, when certain cases further you will blame me. So you give the formula as mu s m, mu s mg. It is mu s into normal. Okay. Why I wrote mu s mg? Now what is the normal here? This is the normal, and normal is balanced by mg. That is why I wrote directly mu s mg. But if it is an inclined plane like this now, it is an inclined plane with theta means if the block is mass m is here means this will be normal. This will be mg. So normal will be balanced by mg cos theta, not mg. So at that time we should not tell Fs is equal to mu mg. It is mu mg cos theta. So you should understand that mu s n is the formula, not mu s mg. Mg in case of this kind of horizontal conditions. Okay, this is the concept. Mu value they will give. This is called as the coefficient of friction. This coefficient of friction will be given. Will be given. So no problem. Normal you have to calculate the mass will be given. Gravity according to the question whether it is 9.8 or you are going to take 10 that is your choice according to the question. Okay. Now let's discuss that JEE advanced question. I hope NLM, Newton's laws of motion, is completed. If not, let me discuss that also. Just certain topics on. Let's say there is a pulley over here. There is a block M, and there is another block capital M. And let's say this capital mass is going to move downwards. So if this is going to move downwards, mg force is going to act due to gravity. Here also small m into g is going to act. Both places tension is going to act same tension because same string only no. Is there different string attached? The same string only no, so same tension will act. But what is the condition here? The mass, capital mass is moving downwards. Small mass is moving downwards. How to frame the equation? First, which is going downwards, you write that force minus tension because this force is dominating this force, that is why it's going downwards. So here mg minus t will be the net force. Then you can write it as capital M into A, mass into acceleration, that is general. Here you need to tell tension is dominating mg force. So here it will be T minus mg equal to ma. If you add both these equation, you will get m minus m into g equal to m plus m into a. Okay, this is one important relation. Okay, from this you can find tension also. By substituting this acceleration here, you will get the tension. What is the tension? T equal to mmg by m minus m plus m. You substitute no? Why? You substitute and you will find out. I wrote wrong formula, that is also a fault. You substitute this A. What A you will get? A you will get m minus m g by m plus m. Am I right? This g no, you substitute it here. Sorry, this A you substitute here. You substitute now, you will get a m value. Okay. Upon simplification, you can solve. This is all about pulley. Okay. And again, one more thing. You think the acceleration of both the bodies is going to differ? No. If this is going with certain acceleration, same acceleration is going to go upwards. Only the direction is going to change. The magnitude will be same. That also you need to remember. Okay. Don't tell both the blocks are having different acceleration. No, that is wrong. Both will have same acceleration. Now let's take another beautiful case. Because these questions, no, it is there in the JBoss material. Without knowing this, you can't solve it. That's why. I mean, I can solve, you won't understand. Okay. So this is a case given. They are asking, what is the friction? Okay. Find the magnitude of the friction. Friction is going to act like this, and this body is going to go down. Okay, tending to go down. Tending to go down. Then what will be the value of friction to prevent the block going down, and this entire system must be in rest. Okay, so what we can tell here, it is capital M into Z. Here is T. The same tension will be here. Why? Same string. Okay. Now here you need to know one thing. This tension must be balanced with this force. Then only this block won't move. Am I right? So we can tell that tension is equal to friction. This tension and this tension same now. If this is not going to move, this is also not going to move. So whether you write it as mg minus t equal to ma, or t minus mg equal to ma, what is the condition here? Video is recording only, no? Recording. Okay. Here, both cases a is going to be 0. So you can write directly t is equal to mg. So that t you substitute here, mg equal to f. Now what is f? Mu into n. What is normal? Small m into g. Why normal is acting like this? This normal is this mg is balanced by this normal. So normal is equal to mg. There is no other vertical forces acting here. So normal is equal to mg. So mu into normal mg is equal to capital M into g. So from here you can get that mu value, coefficient of friction, is equal to capital M divided by small m. Okay, this is one situation. And next, if you are just copy that one, I'll erase now because class no, just going to end. So just rewind, pause, and write if you want, or else just listen and go. Anyways, I'll teach again on the time, it will be helpful for you. So, okay, now let's say there is one block here, and I am pulling this with a rope. So this is going to be the tension, and if this is the friction acting, but the tension that we are giving to this rope node is greater than the friction, so that the block is starting to move like this. So what is the phenomenon here? T minus F is equal to, let's say this is block of mass m, so ma. If friction is going to be 0, then tension will be directly equal to mass into acceleration. So this thing you need to know. If not, we can write T minus mu mg equal to ma, then tension will be equal to m times a plus mu g. Fine. Tension will be equal to m times a plus mu g. So these two cases you need to know. Okay. Now let's solve that J advanced question. So much time waiting for this one, Finally, you got the potential to solve it. Let's once check the question. No, don't need to just waste your time. Let's make sure what we are doing is correct. I mean, the question is correct. I'm not simply giving you any question. Arey, where did that? When I'm searching alone, it is going and hiding somewhere. Oh, impossible. Wait, oh, sorry. I'm searching in friction chapter. How is it available there? Ah, see, that is my mistake only. No, it is over here. Very good. Small m, capital M. Friction is not there. Friction is not there, so you are escaped. Okay. Okay, fine. So the first question they are telling this is one table. This is one table in the horizontal frame, not in the vertical. So one table and here one pulley is fixed. And fixed pulley is there. And there is one small mass m. There's another mass 2m. Another mass of 2m. Now they are telling this entire horizontal table they are going to rotate. Okay. So they are going to rotate this entire horizontal table with a constant omega angular velocity. Now they are asking what is the acceleration of this blocks. Okay, with respect to acceleration of masses as seen from the cabin. The cabin means we are going to see it. Okay. So now you tell me if this is going to rotate, of course this block and this block is going to experience some kind of centrifugal force. What is the centrifugal force that is going to pull the block outside? Am I right or wrong? If the block is going to be pulled outside, can I tell that this value will be equal to 2m omega square r and this value will be equal to m omega square r? And can you tell me which force is dominating? Of course, this force is dominating. So that let's say this is tension. What is the acceleration of the system they are asking? Right, both will have same acceleration. So let's say what is the F net? Net force is this minus this, which is going to be m omega square r r. Okay. And what is the total mass? Mass total equal to 2m plus m 3m. So what is the acceleration of the system? Net force divided by total mass equal to omega square r by 3. This is the question number 1. They have asked what is the system acceleration of the blocks or acceleration of the system. Both is going to be same in this case. Let's note it down. Same question have second one more sub question in that. What is the tension in the system? Okay. Now can we tell that this is going to move outwards and this block is going to move like this? Am I right? So can I tell that this is going to be a system because both are going to have the same acceleration of that of the system. Okay. So which force is dominating here? 2m omega square. So 2m omega square r minus tension equal to 2m into a. Can I write tension is equal to 2m common omega square r minus a. Now we know that a is equal to omega square r by 3. So that can be written as 2 omega square r by 3. How sir you don't ask this omega square r, you keep it here and then subtract. Okay. So now we can tell that the tension is equal to 4m omega square r into 3. Fine. This one J Elon's question. They asked it. Most students know. If you know this concept, you can solve the question, but most of you don't know this place. You won't imagine. So that's the problem. Otherwise, this question is very simple question. Actually, no need to be asked in CE advance. Such an easy question, but unfortunately, they have to be asked in CE advance. Okay. So now copy this. We will go to the next question. So okay, this is going to be the next question. So the next question states that there are two blocks M1 and M2 placed on M2 on a table which is rotating with an angular velocity, constant angular velocity omega with the vertical axis. Okay, this entire system is going to rotate like this. Okay, so they are asking the frictional force between the surface, contacting surface, that is between the M2 and mu. No. Between these two, I guess. Okay, fine, we'll find, no problem. We'll just write all the cases. So, can you tell that free body diagram of this mass M2? So, this is going to experience some kind of force outwards, that is the M omega square R. Right, M2 omega square into radius. And this is going to be balanced with the friction over here, which is nothing but, let's say, F2. Now, let's say there is mass M1 over here. No, you think this block is going to move outwards, no, with what force we are applying here, M omega, M1 omega square R. And because of this, do you think the friction is going to act this side? Of course, you will tell that the force is acting in this direction, in the opposite direction is going to move, no. See, here the block mass is going to move faster than the capital mass. Am I right? So when you see from this frame, when think that you are in mass M2 and you are seeing at mass M1, so it is going to go like this or it's going to go like this. I mean, I'm sorry. So larger mass is going to go away than the smaller mass. So this is going to move faster than the smaller mass. Why heavier mass is equal to more centrifugal force. So that this mass is going to go faster than this mass, so that relative to this mass appears to go in the opposite direction. Can you understand? See, you are imagine you are sitting in this block and you are watching this block. So this block is just going to come with you, but relative to this block is just slowing down. Okay, this is going little backwards relative to this block, but relative to our frame, that is a ground frame, this block is also moving in this direction. But in relative frame, this is moving in this direction, so that friction will act in this direction. Let's say this is F1. So if this is F1, then automatically due to internal force balancing, here also F1 force will be acting. So let's tell that F1 plus F2 equal to M2 omega square, or what is F1? What is F1? Mu1 times M1G plus mu2 times M1 plus M2 into G, if I am not wrong. M2 omega square R. Now can I take M1G common? M1G common if I took now. Mu1 plus mu2. I'll get, and I'll get M2G also equal to M2 omega square R. Okay, what they are asking? Let's see. Cylinder velocity. I'm making a mistake. F1 and F2 is connected in this section. Okay. See. Here normal, no. It's not M1 plus M2G. It's just M2G. Here you should not take like that. For this block, it is going to be M2G only. Mu M2 G equal to M2 omega square, uh, so that you can tell that, uh, so 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 that, Again, there is one problem. Is there any problem? M1 plus M2 omega square R. Okay, 1 minute. Wait, let me cross check once. Okay, fine, fine. The problem, what we didn't know, what is the wrong now? We assumed that this particle is going to slip, but they didn't tell that it's going to slip. It's going to move together. So that our assumption is wrong. J1 question little bit like that relatively. So to be conceptually clear, else we can't solve any questions. Okay, that's the pen. Okay, so the point is that both the masses we are going to take it as together mass. So we can call this as even though this is m2 and this is going to be m1. The here the force is going to be acting m1 plus m2 omega square r, and this side is going to act a friction. Okay, so basically the friction that is acting will be equal to m1 plus m2 m1 plus m2 times omega square r. That is point number one. And next they are asking that maximum angular velocity they are asking. So to find that maximum angular velocity, can we tell that hmm, can we tell that can we tell that mu times m1 plus m2 into g equal to m1 plus m2 into omega square. From this we can tell m1 plus m2 get cancelled and this is going to be mu2. So maximum omega that we can apply will be equal to mu2 g divided by r. Right, this is omega square. If you remove this square, you will get square root. So maximum omega that can be applied will be equal to root under mu2 g by r. So these are the two questions asked in the JEE Advanced season. Hope you are clear with this. So the next part of the circular motion will be afterwards only. After this, make sure you are clear. Okay, thank you. Bye.